Hello everyone, welcome to Session 7 of LTEC 676, Social and Ethical Issues in Educational Technology. In this week's video, we're going to cover three topics. First, we're going to continue our focus on differing educational outcomes. Then, we're going to explore the concept of compounding inequalities as explained by Linda Darling-Hammond in her 2007 article. And we'll close out by discussing problem solving and the need for problem solving competence in the 21st century. So let's get started. As we've talked about the previous weeks, we've been studying how we assess equity and equality inside schools, and namely that we can assess inputs, processes, and outcomes. For now, I want to focus on outcomes, or what are the results achieved by U.S. schools. I'm sure you're all familiar with the Pisa Test, or the Program in International Student Assessment. What you can see here is how, in a number of different areas, reading, science, math, and problem solving, we can compare how U.S. students as a total do compared to all of the countries in OECD, which stands for the Organizations for Economic Cooperation and Development. And as you can see, in reading, we're just a little bit above the OECD average. In science, the US is below. Math, we're quite a bit below. And on problem solving, we're even further below. What's interesting, and Linda Darling-Hammond shares this data with us, is the fact that when we start to look at subgroups in the United States, we can see there are major differing educational outcomes. For example, if we take a look at reading, here in the gray box you're seeing the average score of white students in the U.S., the average score of Asian students, and the average score of multiracial students in the U.S. Now let's compare that to the reading scores of Hispanic and Black students as shown here. And we can see there are major differences in the educational outcomes of those subgroups. And of course, the same trend holds for science and for math and for problem solving. So if we assess equity and equality in schools based on this outcome, it's clear that our schools are not equitable in terms of educational outcomes. Now let's talk a little bit about how this information is interpreted. Well, there are presumptions and explanations that are common. And Darling-Hammond points out that there's a pervasive presumption that equal educational opportunities now exist in the United States. So how do people explain the differences in the educational outcomes just shown on the 2003 PISA assessment? Well, she says that some of the common explanations for differing educational outcomes include blaming children, their families, and their communities for a lack of effort, poor child rearing, a culture of poverty, and inadequate genes. In other words, some people blame the victims of systemic inequity because they assume that there is now equal educational opportunity in the United States. However, Darling-Hammond points out that educational outcomes for students of color are much more a function of their unequal access to key educational resources, including skilled teachers and quality curriculum, than they are a function of their race. Linda Darling-Hammond introduces this concept of compounded inequalities, and this ties nicely into our illustrated analogy, and we can ask ourselves, why is the ground uneven? And Darling-Hammond explains in so many words that the ground is uneven because of 200 years of slavery, 100 years of court-sanctioned discrimination based on race, the idea of separate but equal, and then 50 years of differential access to education by race, class, language background, and geographical location. And she argues that 50 years since Brown versus Board of Education, the gaps in educational achievement between white and non-Asian minority students remain large. And, most importantly, the differences in access to educational opportunities are actually growing. Now, why does she argue that those differences in access to educational opportunities are growing? Now, to help us understand that, I want to introduce a concept called the instructional core. And this is a concept introduced by Richard Elmore of Harvard University. And he and his colleagues argue that there are only three ways to actually improve student learning. You can raise the level of content that students are taught. You can increase the skill and knowledge that teachers bring to teaching that content, or you can increase the level of students' active learning of the content, their engagement. And according to Elmore, that's it. Everything else is just instrumental. But if you really care about improving student learning, you need to focus on these three components of the instructional core. Now, how does this connect to the concept that differences in access to educational opportunities are actually growing or getting worse? Well, let's talk about Darling-Hammond's finding that by every measure of qualification, less qualified teachers are found in schools serving greater numbers of low-income and minority students. In other words, for those schools that serve the greatest numbers of low-income and minority students, their teachers have fewer certifications, they have less background in their subject matters they're teaching, they have less pedagogical training, they attend less selective colleges, their test scores are lower, and the experience that they bring to the classroom is lower. And for those reasons, we are seeing that one leg of the instructional core is hobbled for the students attending schools that have greater numbers of low-income and minority students. A question for us is the focus on technology. An essential question is, how can we leverage technology to ensure more well-qualified teachers? What role does educational technology play in solving this particular set of problems? Now, on the other side of the instructional core, we have the issue of content. And Darling-Hammond points out that students of color face stark differences in courses, curriculum materials, and equipment. She reports that the schools attended by students of color offer fewer college prep courses and advanced coursework. They have more remedial courses, smaller academic tracks. They emphasize more vocational programs. Their instruction deals with lower level cognitive tasks and rote memorization, and there are fewer opportunities for students to read real books, research and write, and construct and solve problems. So again, we're seeing another component of the instructional core hobbled in this scenario. And another essential question is, for us studying educational technology, is how can we leverage EdTech to create more engaging, higher order content for students to engage with? How can we level the playing field through the use of technology? Now, these are essential questions, and I want to point out how important and time-sensitive these questions are. And we'll do that by focusing on the increased need for problem-solving competence in the 21st century. Now, to do that, let's come back around to the 2003 PISA results. And I want to focus just for a moment on problem solving. We could see that we're performing less well on problem solving compared to the other countries in OECD. Of course, if we look at the US subgroups, again, we're seeing a massive gap. Now, why am I focusing on problem solving? Well, a 2014 report emphasized the importance of problem-solving competence, which they defined as an individual's capacity to engage in cognitive processing to understand and resolve problem situations where a method of solution is not immediately obvious. In addition to that, it includes the willingness to engage with such situations in order to achieve one's potential as a constructive and reflective citizen. Now, a similar report talks about that in the 21st century, problem solving is really a fundamental skill that is very sought after by employers because of a shift in the type of job skills that are required by employees. And one particular report talks about the following 5 skill categories. routine manual skills, that's repetitive production, maybe working on an assembly line. Routine cognitive, where you're not necessarily using your body to do manual labor, but you're just simply entering in data. You're not really thinking. It's very routine, but it's different than manual labor. Then we have non-routine manual, which is something like preparing a meal. And then we have tasks that are non-routine abstract and analytical, and that involves actually transforming data. And then we have skills that require non-routine abstract and interpersonal skills, such as managing teams. These skill definitions are important because if we look at the types of jobs and the skills that they are requiring and how they've changed over time in three major economies, Germany, the United States, and Japan, we can see that routine cognitive and routine manual are dropping significantly. This is important because the areas in which people can get jobs is changing, and the types of skills they're going to need to get those jobs and participate in the economy and to be productive citizens is drastically changing. So another question we need to be asking ourselves as people focused on educational technology is, how can we leverage technology to improve students' problem-solving abilities? In other words, we want to get the average problem-solving ability of students in the U.S. First, we want to address inequities. And secondly, we want to make all students more competitive in terms of problem solving relative to other developed nations in the world. Okay, we're out of time for today. I just want to end on that we're going to be moving into our second unit, which is going to focus on racial and ethnic divides, differences, and needs. And we're going to do that by focusing on a book called Disruptive Fixation, written by Christo Sims. Okay, everyone, have a great week. I'll see you in Canvas.